Hello everyone, I am Ms. Megha Karwal, Department of Civil Engineering from Praveen Patil College of Diploma Engineering and Technology. In this lecture, we are going to start sleepers. These are the members laid transversely under the rail for supporting and fixing them at the gauge distance. Apart are known as sleepers. Functions of sleeper: they maintain alignment of track, they hold rails in proper gauge firmly and evenly, they distribute load over a large area of ballast, they absorb vibration caused by train, they will act as an elastic medium between rails and ballast. They not only supports rails, but they also help in maintaining proper super elevation on curves. They provides overall stability to the track. Requirement of good sleeper: they should be suitable for track circulating. They should have very high scrap value, minimum initial and maintenance cost, moderate weight, easy to handle. Fixing and removing of fastening should be easy. Sufficient bearing area, easy maintenance and gauge adjustment. Track circuiting must be possible, able to resist shocks and vibrations. Now we will start types of sleepers. There are various types of sleeper which are used on a Indian railway. So they are classified as follows. First is wooden sleeper. Second is metal sleeper. In metal sleeper, there are two types: steel sleepers and cast iron sleeper. Third is concrete sleeper. For first is reinforced concrete sleeper and next is pre-stressed concrete sleeper. Now we will start with wooden sleeper. What is wooden sleeper? Wooden sleepers are regretted to be a best as they almost all requirements of an ideal sleeper. The life of timber is depend upon the ability to resist wear decay attacked by wormy white ants. Okay. That quality of timber. Advantages of wooden sleeper: easy to manufacture and handling, suitable for track circulating area, can be used with the or without ballast, suitable for all type of ballast, fitting are few and simple in design. Alignment can be easily corrected, easily available in all part of India. Disadvantages of wooden sleeper: lesser life like 12 to 15 years, liable to damage by better packing, difficult to maintain the gauge, and susceptible fire hazard. Next is metal sleeper. Metal sleepers are either steel or cast iron. Cast iron is in a greater use than the steel for the sleeper, less prone to corrosion. That's due to the growing of shortage of timber to be used for wooden sleeper, their high maintenance cost and short life. Metal sleepers are now being widely used in India. Steel sleeper. In India, thousands of kilometers of track has been laid using steel sleeper. It is an inverted channel with the folded ends. The folded edges which form a bulb resist the damage caused by the packing of ballast. So these sleepers consist of the 6 mm thick steel plate pressed in the form of inverted channel or through with the folded ends. The folded ends which form a bulb check the running out of the ballast at the time of pressing the steel sleeper. Their rail seats on either side is given an inward slope of 1 in 20 to achieve the requirement of tilt of rails. The standard length of this sleeper is 2.68 meter. Now the advantages of steel sleeper is longer life is 30 to 40 years, better stability, lesser damage during the handling and transport, easy to maintain gauge, simple manufacturing process, high scrap value. They are not attacked by vermins. They are not susceptible to fire hazard. Disadvantages: steel sleeper liable for corrosion, not fit for track circulated area, develops cracks at the rail seat during service. The overall cost of steel sleeper is more than that of a timber sleeper. Fitting required are greater in the number of difficulties to maintain the inspection. This is an image of steel slipper. Type of steel slipper, key type steel slipper, and clip and bolt type of steel slipper. In first image, in this type of a steel slipper, wedges or keys are used for holding the rails in pressed up the lugs or in a loose jaw fitted on either side of rail seat of the slipper. The legs are formed by pressing out of the metal of the inverted through a channel section as shown in a figure. Okay, in a clip and bolt type of steel slipper, clips and bolts are used for holding the rails as shown in a figure. For connecting each rail with this type of steel slipper, 4 clips and 4 bolts are used. In this type of a slipper prevents a grip effectively. These steel slippers can also maintain the excellent gauge, but however they are not being used in Indian railways nowadays. Next type is cast iron slipper, extensively used in India and on a small scale in South Africa. So type of cast iron type of cast iron sleeper is pot or bow sleeper, plate sleeper, box sleeper, CST, 9 sleeper, rail free, duplex sleeper. The sleeper made of cast iron are known as a CI or cast iron sleeper. Cast iron sleepers are being extensively used on Indian Railway, and about 45% of the track at present consists of CI sleeper, which may be either pot type or plate type. So first image is pot or bowl type sleeper. Next is CST9 sleeper. Cast iron component has a shape combining of pot, bowl or plate. Widely used in India. Concrete sleeper. Concrete is proved an ideal material for the sleeper. Concrete is a strong homogeneous material impervious to affect the moisture. It is molded easily to size and shape. Advantages of concrete sleeper: great stability, track geometry maintained for much longer duration, hence economical, best suited for machines maintenance, suitable for track circulating area, no chances of damage by fire corrosion, rail and sleeper connections are strong, no chances of gauge widening. The sleepers are required less fitting. Advantages of concrete sleeper: handling and laying is difficult, being heavy, no scrap value, not suitable for manual packing. There are following 2 types of concrete sleeper: RCC means reinforced concrete sleeper and pre-stressed concrete sleeper. RCC sleeper. The concrete sleeper constructed of reinforced cement concrete are known as RCC sleeper. RCC sleepers are of the following 2 types: monoblock sleepers and 2-block sleeper. Monoblock sleeper. This type of RCC sleeper is also known as a one-piece or throw type sleeper. It consists of a member of reinforced cement concrete of suitable dimension like a wooden sleeper, and inverted slope of 1 in 20 is provided for a distance 175 mm on either side of center line of the rail seat as shown in the figure. 2-block sleeper. This type of a RCC sleeper is also known as a block and tie bar or composite type sleeper. It consists of 2 blocks of reinforced cement concrete. 1 block is placed under each rail. Both the block connected across the track by means of metal tie bar, usually in the form of inverted. Pre-stressed concrete sleeper. The concrete sleeper constructed of pre-stressed cement concrete are known as a pre-stressed concrete sleeper. In this sleeper, the concrete is put under the heavy high initial compression. All the disadvantages of RCC sleeper have been eliminated by pre-stressing technique used in this sleeper. But these sleepers are heavily damaged in case of de-alignment or accidents of trains. So these sleeper are used for longer life of spine, can be used in a high speed tracks, can be withstand static and cyclic load. This uneconomical. These are the advantages of pre-stressed concrete sleepers. Sleeper density. Sleeper density is the number of sleepers per rail length. It is specified as a m plus x or n plus x, where m is length of the rail in meter and n is a number varies to factor. The density of sleeper is mainly depend upon the following factor, like actual load which the track is accepted to carry, speed of the train, the lateral thrust of locomotive, and methods of providing rail joint. The number of sleepers, however, cannot be increased identifiably since a certain minimum space in between any two sleepers is required for packing of ballast. In India, the packing of ballast is kept 30.5 to 35.5 centimeter, except at joints. Ballast. The granular material spread on the formation of a railway track for the sleeper to rest upon is known as a ballast. Requirements of good ballast. Ballast should be strong, durable, clean, economical, provide good drainage, stable, no harmful effects on rail and sleeper. Functions of ballast: to provide cushion effect to the track since it is an acts as an elastic medium in between the sleeper and the formation, to provide firm bed for the sleepers to rest upon, to uniformly distribute the load of trains from the sleepers on a large area of the subgrade or formation, to hold the sleepers in a correct position and thus preventing their lateral and longitudinal movement, to provide an easy means of maintaining the required level of the two rails in a track and correcting track alignment, to drain off the rainwater from the track quickly and to provide a well drained foundation bed immediately below the sleeper, to protect the top surface on formation, to prevent growth of weeds inside the track. These are the type of railway track ballast: broken stone, gravel, ashes, sand, murum, concrete, brick ballast, and selected earth. Thank you.